Welcome all. My name is Dr. Mahender. So I'm working as assistant professor in Institute of Aeronautical Engineering. So today I'm going to explain conductivity experiment. Okay. So my this is engineering chemistry lab. So I'm going to explain the conductivity experiment. So the topic today, my topic is to determine the strength of an acid by conductometric titrations. Okay, this is an experimental lab. And first I will explain the aim of the experiment and principle and procedure. Okay, this is engineering first year. It will have conductivity experiment. So the name of the experiment is to determine the strength of an acid by conductometric titrations. So this is and this is also called as strong acid versus strong base. Okay, so what is the aim of the experiment is to determine the strength of acid by titration with strong base conductometrically. Okay, so this name is called conductometric titrations, and it is also called as to find out the strength of an acid. And other name of this experiment is also called as strong acid versus strong base, determination of unknown concentration of an acid. Okay, so apparatus. So what are the apparatus required for this experiment? Okay, this is a digital conductivity meter, conductivity cell, burette, beakers, a measuring cylinder, and burette stand. So these are the apparatus required for this one, and furthermore we also require the burettes and the pipettes also will require for collection of the sample. So then what is the chemicals required? So what are the chemicals required for this experiment? Distilled water, sodium hydroxide, hydrochloric acid. So in this experiment, what is this experiment? In this experiment, what we have to find out is we are trying to find out the concentration of HCl. So we know that concentration of HCl is an example of a strong acid. So concentration of HCl, we have to find out the concentration of HCl by using the concentration of strong base, that is NaOH. This name, that's why the name of this experiment is called strong acid versus strong base. So by using the concentration of strong base, we are finding out the concentration of an acid. And this experiment is called conductometric titration because by using the conductivity meter, we are trying to find out the concentration of HCl. So that's why this experiment name is called conductometric titration. So these titrations will be based upon the concentration. These titrations will be based upon the concentration of the HCl. We know that solutions will conduct electricity based upon the movement of ions. Whether the solution may conduct electricity when it is in acidic state or in the basic state, the solution which is in a neutral state does not conduct electricity because there is no movement of ions. We know that the conductivity of any solution is because of movement of ions. The conductivity of any solid substance is because of movement of electrons. So in a neutral state there is no movement of ions. So the solution which is in a neutral state does not conduct electricity, and also HCl, if you see the conductivity of the HCl, if the HCl is very strong, the conductivity is more because the number of H plus ions will be more. If you see the sodium hydroxide, the conductivity is more, means that is a strong acid. So strong acid will have more conductivity when compared to the weak acid. So we know that what is an acid Acid means which gives H plus ions in when we dissolve in water is called acid, which gives OH minus ions is called base, which sparingly dissolves or which easily ionizes H plus ions is called strong acid, which slowly ionizes is called a weak acid. Okay, so as it is same for the base, which gives OH minus ions is called base, slow or sparingly soluble and sparingly it will give OH minus ions, it is called weak base. So what is an example of a strong acid? So example of strong acid is HCl, weak acid is acetic acid. So example of strong base is sodium hydroxide, weak base is ammonium hydroxide. Okay, so by using this acid base, so other name of this is also called as acid base titration. So we can also find out the concentration of HCl by using volumetric analysis. But in the volumetric analysis, we require some indicator. So indicator means when it will be neutralizes. But in this conductometric titrations, it does not require any indicator. Okay. So moving to the principle. So this is a chemical required. So moving to the principle. At first solution, H plus ions and Cl minus ions. Since H plus ions possess greater mobility, it follows the conductivity is mainly due to H plus ions. The addition of NaOH is represented by the equation. So you can see the equation HCl plus NaOH gives rise to NaCl plus H2O. So when we add, we know that HCl is a strong acid, NaOH is a strong base. So when we add acid to the base, so what will happen? At a certain time, it will neutralizes. It will neutralizes and gives rise NaCl plus HCl. Okay. So as NaOH is added, so in this experiment, so what we'll do? We'll fill the burette with sodium hydroxide and we'll take HCl in a beaker and slowly we'll add NaOH to the acid. So what will happen? Acid, when we add base to the acid, after some time it will neutralizes. So as NaOH is added, the H plus ions are removed. The conductivity decreases as Na plus ions do not possess much mobility. As a neutralization point and solution contains Na plus and Cl minus ions will have minimum conductance value. If NaOH is further added, the increase in conductivity is because of OH minus ions. So the principle is simply that. So when we add NaOH to the HCl will neutralizes. As the HCl will neutralizes, so the conductivity of the HCl will slowly decreases and it will come to the neutral. Again, once the neutral is attained, even though if you are adding NaOH, again the OH minus ions increases, again slowly the conductivity of that experiment, the conductivity of the solution increases because of the movement of ions. So we can see this is a conductivity meter. So this is a conductivity meter. So this is a check one and this is a temperature. So temperature always will keep in 27 degrees centigrade and this is a cell constant. With the help of this cell constant, so we'll keep the cell constant always 1. In this experiment, we'll keep the 1 because we'll use a conductivity cell that which contains the constant is 1. So this one, so this has a 3 modes. So cell constant mode and conductivity mode, check mode. So when we are checking, so we'll keep this mode. So when we are measuring the conductivity, so we'll see this one. And when we are adjusting the cell constant, we'll put in this mode. And this is a unit. So what are the units of conductivity? Conductance is nothing but microsiemens. Siemens or microsiemens. Siemens is nothing but ohm inverse. The conductivity, the units of the conductivity is Siemens or ohm inverse. Okay. So the conductivity of the solution is very less. So that's why we'll calculate the conductivity in microsiemens. Okay. So this is a conductivity instrument. With the help of this conductivity instrument, so we are going to estimate the conductivity of the solution. Okay. So procedure. So what is a procedure? So first, a standard solution of 0.2 NaOH is prepared. So how to prepare 0.2 normal NaOH? So how to prepare 0.2 normal NaOH? Normal. What is the formula of normality? Normality is equal to weight of solute or weight of salt by gram equivalent weight into 1000 by volume in ml. Okay, by using this formula, so we'll calculate. So how much amount of NaOH we require? So we require 0.2. So here we'll keep 0.2, and suppose we'll keep here x, and here gram equivalent weight is 40 by 1 into 1000. Suppose if you want to prepare this for 1000 ml, so 1000 will get cancelled. X is equal to 40 into 0.2 grams. So we have to add x is equal to this many grams, 40 into 0.2. Okay, so this many grams we have to add in a distilled water, so that we'll get the 0.2 normality. Okay. Okay, students. So in this manner, so we'll calculate the normality of NaOH. So why we have to prepare the normality of NaOH? Because we require the 0.2 normality of NaOH. Okay, then this one is over. So standardization of solution of 0.2 is over, right? So similarly, 20 ml of HCl is taken in 100 ml beaker. Okay, the conductivity cell is washed with a distilled water. Okay, the cell is kept in acid containing beaker and it is connected to the bridge. So this how will connect to the bridge? So I will show in the video. Okay, the cell is kept in acid containing beaker and is connected to the bridge. The conductivity of the cell is measured adjusting the reading. And sixth step, what we have to do? NaOH is taken in a burette. So we have to, which NaOH we have to take? 0.2 normality, which we have prepared, that we have to fill in the burette. And 1 ml of solution acid stir well and conductance is measured. So what we have to do? We have to fill the 0.2 normality NaOH solution in the burette and in the beaker. So we have to take the acid, that acid constant, which acid we have to find out the strength of that acid, we have to take in a beaker. We have to take in a beaker. Okay, each 1 ml of base is added to acid, stir well and conductance is measured. So each time, so what we'll do? First you fill the burette with NaOH, then you take the sample whose concentration has to be determined, that you take in a 20 ml and you keep in the beaker. Then you take one reading. What is the conductance? What is the conductance of the HCl before adding the base? Then you note down. You make a table like this: serial number 1, volume of NaOH and observed conductance. Okay, serial number 1, volume of NaOH, observed conductance. So serial number 1, you will take the HCl and you should not add any NaOH. Then you take the conductance reading. So you write here what is a conductance. Then second step, what we'll do? Stir well and again you add 1 more ml of NaOH. Then you note down the reading. So you note down the reading. So like that, you add 1 ml of NaOH from the burette and you take the readings of conductance. Again you add 1 ml and again you take the conductance value. So like that, you repeat this same for the 10 readings. So 10 to 15 readings. So you will collect it. Okay. So each time 1 ml of base is added to acid, stir well and conductance is measured. Okay. For every instant, equal number of values are taken on other side of the point to point of maximum. So what is this meaning is, so suppose how much conductivity, suppose if the HCl conductivity is around 14. So until again it will attain the 14, so you take up to readings until it will attain the 14. Okay. So repeat the procedure of addition of 1 ml NaOH and nothing the conductivity of the resulting solution is solution. Take 20 to 25 readings. So take 20 to 25 readings, or you will take the readings until at what reading it has been started till you get that reading, so you have to take. Okay. Then after this, so what you will take after you taking the readings of 15 to 20 readings, so now you make a graph. Volume of NaOH on the x-axis, conductivity on the y-axis. So this is suppose 1 ml, 2 ml, 3 ml, 4 ml, 5 ml, 6 ml, 7, and this is 8. So like this graph you'll get, and if you plot a graph, so you will get V-shaped graph. So this is called neutralization point. This is called neutralization point. This is called neutralization point. Okay. So how we will get the graph? This graph. So you will get the graph by plotting volume of NaOH on x-axis, conductance values on y-axis. Okay. So then this is the tabular column. So we have taken the readings. Right. So then what is the formula? So N1 V1 is equal to N2 V2. So how do you calculate? So this one N1 V1 is equal to N2 V2. Okay, this will continue after how this experiment will be shown. Okay, so I will demonstrate this experiment. So I will do and I will show. Okay. So for this experiment, so we require the concentrated HCl and the NaOH. So NaOH is a base and HCl is an acid. So today we are going to estimate the concentration of HCl by knowing the concentration of NaOH. Okay. So this is first we have to prepare the concentration of NaOH. So concentration of NaOH, so we will prepare 0.2 normality. First we have to prepare the 0.2 normality NaOH. So how we will prepare? By using the normality formula. So first we will prepare the 0.2 normality of NaOH solution, and this is a HCl, and this is a HCl solution. So we have to determine the concentration of this HCl. So by knowing the concentration of this NaOH, so we are going to estimate the concentration of HCl. So we know that this is called acid base titration, and this name is also called as strong acid versus strong base. So we know that NaOH is a strong base and HCl is a strong acid. So by the titration of this also we can determine, but today we are going to estimate by using conductivity meter. So we know that the conductivity of the solution will depend upon the movement of ions. So we know that conductivity of solids will depend upon the movement of electrons. The solutions, if you see, the conductivity of the solutions will depend upon the movement of ions. So if you see the solution in any neutral case, so that does not show any conductivity. The solution of the base will show conductivity because of OH minus ions. The solutions will show conductivity below 7, that is H plus ions. So as the movement of ion changes, so then the conductivity also changes. By using this principle, so we are going to estimate the concentration of unknown acid. So we can also identify the concentration of unknown base, but in this experiment we are trying to estimate the concentration of HCl. So this is digital conductivity meter. So this is digital conductivity meter. So it will digitally displays the conductivity of the solution. So this is a checkpoint and this is temperature. So always we have to keep the temperature in 27 degrees centigrade, and this is a cell constant. So cell constant, and this is a function. So we can use in cell constant mode or conductivity mode or check mode. And this is the units. So we know that conductivity units is a microsiemens. So our conductivity range will be in 200 to 20 to 200 microsiemens. So that's why we have kept here, and we have kept this mode also 200 microsiemens. And then first what we have to do, first we have to take in the burette, we have to fill the burette. This is a burette. In the burette we have to fill the concentration of NaOH. We know that concentration of NaOH is known. So we have to fill the burette. So while we are filling the burette, so we have to, first we have to close the knob here, and we have to fill the burette. So when we are filling the burette, so we have to fill extra more than 0. So then we have to adjust it to 0. Right. So now it is 0. So I kept in a burette stand, and this is a electrode. So this is a digital, this is a conductivity electrode. This is made up of a platinum. So it will be connected to red one, and this is a phase, and the neutral. It is connected to phase and neutral. So it will digitally, it will displace the conductivity of the solution. Based upon the conductivity of the solution, so we are going to estimate the concentration of HCl. So this is a HCl. So we are going to estimate the concentration of HCl. So first we will take 20 ml. So we can take with a pipette, or we can also take, this is a measuring cylinder. So we will take the 20 ml. 20 ml, so we can take the 40 ml. Right. So this is a 40 ml, 40 ml of HCl. This is unknown concentration. Right. So this is unknown concentration. Then we have to dip. This is an electrode. So whose concentration has to be determined. It has to be dipped in this one. So it digitally displays the conductivity of this solution. It digitally displays the conductivity. So now you see the conductivity of this solution is 17.73 microsiemens. So now after this, so after we are taking, so in this one, this is a HCl and this is a NaOH. So we know the concentration of this NaOH, and we are trying to estimate the concentration of this HCl. So we have prepared this solution. This is an unknown solution. So if we take dropwise, then we have to add, slowly we have to add the 1 ml of NaOH. Right. So we have to add the 1 ml of NaOH, and we can stir. So now you see the conductivity of this one is 17.74. So slowly if we add 1 ml, 2 ml, 3 ml, the conductivity of this one will decreases. Conductivity of this will decreases because we are adding the base. We are adding the base. This is a acid. So it will neutralize at one point. Right. So after we are taking these experiments, so we'll draw a table. Serial number 1, volume of NaOH and absorbed conductance. So initially we have not added anything. This we written as 0. So the conductivity is around 17.1. So after this, then we'll add 1 ml of NaOH. Then we'll see the conductivity. So like that, we'll see now the conductivity is 17.83. See, conductivity is 17.83. So we'll add 1 ml. Right. See, the conductivity is decreased to 17.19. So like that, if we are adding 1 ml and we are measuring the conductivity, so slowly the conductivity will decreases. So the conductivity decreases, and the minimum point is, here minimum is 4.8. So we'll get the 4.8 where the neutralization is attained. Okay. Then again after the 4.8, it slowly
slowly it increases. Again it increases 6.9, 7.5, 9. So like that it will again increases. So it will, after the calculations, so when you draw a graph by taking volume of NaOH on x-axis and conductivity on y-axis, so we will get the V-shaped graph. V-shaped graph, so that V-shaped graph, if you join all the points and if you find out where you get the neutralization, so that is your neutralization point. So after the drawing the graph, so we will get N1 V1 is equal to N2 V2 from this formula, so we can calculate the N2. N1 is a normality of NaOH, so we have calculated, and N2 is a normality of HCl, we have to determine. V1 is the volume of the NaOH, so we will get by the burette reading, and V2 is volume of HCl, which we are calculated from the graph. So from this we can calculate the strength of the HCl.
So how you will calculate? So this side, so when you are calculating, so how you will write this side? So suppose this is NaOH on left side and HCl on right side. Okay, so this one N1 V1 and this is N2 V2. So what is a N1? So N1 is 0.2. Why it is 0.2? Because we have prepared this one. N1 is 0.2. 0.2. So what is a V1? V1 is burette reading. So this is burette reading. Burette reading. And what is N2? N2 is normal. So this left side, N1 V1, N1 V1 all belongs to the readings of NaOH. Right side, HCl, all values belongs to the HCl. So this we have to find out. So what is a HCl? What is a volume of HCl? So we have taken the 20 ml. We have taken the HCl. Yes. Okay, we have taken, this is not the burette reading. This is from graph. Sorry. So this is from graph value. So how we will get the graph value? Suppose we are getting this value. So volume, how we are getting this graph value? How we are getting this graph value means, so you have to draw, this is graph, this is x axis, so this is y axis. Okay, so we are getting the graph like this. Okay, and this is our neutralization, and this is 0, 1, 2, 3, 4, 5, 6, and this 1, 2, 3, 4. Okay, and this is our neutralization point. This is our neutralization point. So this is volume of NaOH. Volume of NaOH in ml. So this is conductance. This is conductance. Okay, conductance unit is mu or Siemens. Okay, so now this graph value from the graph, so you draw a straight line. This is 4 means this is a 4 ml you are getting. Okay, so therefore, so and another important thing is, so when you are plot a graph, okay, so from this we will get the graph, and now you can calculate what is a N2. N2 is equal to N1 V1 by V2. So now you calculate the N2. So N2 is nothing but your normality of the HCl, that is a strong acid. And another important thing, so when you are plotting a graph, so when you are plotting a graph, we have to follow certain rules. Volume of NaOH, and this is conductance. Okay, so this is This is conductance. So what will get? So when you are plotting graphs, so you will get like this, like these points. Okay. So you will get like these points, like this. So what you have to do? So you have to draw a straight line which intersect. Where the 2 points will intersect, that you draw a perpendicular line to the x-axis. Okay, perpendicular to the x-axis. So this is your volume of NaOH. Okay, this is your volume of NaOH. From this, so you can calculate the concentration of this one. Okay, students. So from this we can calculate the volume of NaOH, and will determine, here we can write the normality of HCl. And these are the reference textbooks, so you can go through these reference books to understand more about this conductivity experiment. Okay.
Like, share and subscribe. Hit the bell icon for more updates.